Bum bum bump dum bum bum. Trying to get righty. Let's see. Live stream. Sorry if you're watching this. I'm not to my chat yet. All right, here we go. Let me go ahead and edit this so you know what I'm doing. Let's see. Yep. So data structures in GameMaker. Live tutorial. Yeah, I should have had this written out. So if you're watching this in the future, yeah, congratulations, you get to watch me set up my stream. Okay, so learn data, learn the list, queue, and stack data structure in GameMaker. Alrighty, so we're good to go. So yeah, I'm gonna be talking about data structures in GameMaker. So if you've ever wondered how to use them, whatever, this is going to be another primer video for my multiplayer networking series, because we're going to be using lists and stacks at least pretty extensively, and I'm sure we'll come across some uses for the queue data structure as well. So the first thing we're going to do is kind of go over the functions of the different data structures. So well, actually, let's talk about what a data structure is. So essentially, a data structure is just basically a wrapper around maybe just the basic array data structures. So hopefully you're familiar with arrays. If not, I'll try to link down below my array videos so you can get familiar with those. But what I'm saying is you could create an implementation of any of these data structures using arrays. You could get the same functionality. For example, a stack has a create, destroy, clear, empty, size, copy, top, pop, push, read, and write function, okay? You could create a structure in GameMaker or in any other language that you could use arrays, but it could have you could have a script for all of these different things, and they would get the same functionality out of it. So these data structures are a way for you to store data basically into an array. It basically is an array on the very bottom, okay? Or some kind of list of elements, and some functionality to do work with those elements. So let's kind of go over the most basic data structure real quick, and that's going to be the list. So let's go ahead and read about the list. If I go back, give it back to me. Let's read about the list real quick. Okay, so a DS list is a data structure that stores information sequentially as it is added, much like a one-dimensional array. DS lists are very flexible data structures that permit you to add values at the end or insert them somewhere in the middle of a list. So let's go ahead and talk about this. If you have used an array and your array, you've wanted to insert something in the middle of that array, you've had to manually move all of the elements that should be after that place you inserted. So you're inserting here, you have to move everything above it up, and you have to manually do that with just an array. The DS list functions do that for you, so you can use the insert command and it will push everything else up. It's still working fundamentally the same as an array, unless they have this implemented as a linked list, which is different, which I don't know if it tells you up here if it is or not. But whatever, it doesn't matter. It does it for you. You don't have to worry about programming it a certain way. You just say, I want to insert a new element, and it's going to put that in there. So let's go ahead and kind of go over a little example. So let me actually write in here. We're going to do DS list create, okay? This is how we create a data structure. And this is going to be in the create event. You could do this anywhere. You could do this all inside of one script if you wanted. And anytime you use a create with a data structure, you need to also use a destroy or delete. I forgot what the DS list delete. or no, it is destroy. Okay. Sorry, I got those backwards. Delete will actually remove an element from the list. Destroy actually destroys this data structure, which we need to do. So when you're done using a list or data structure, you can actually use ds list destroy, okay? And you have to pass it an ID of a list to destroy. And how do we get the ID of this one we created? Well, we just save it to a variable. So we say our list equals ds list create. And then when you're done using it, our list gets destroyed by ds list destroy. And if you're not familiar with why we need to destroy these variables, it's because GameMaker does not automatically clean this up for you, okay? So basically, I think, let me see. I believe it'll actually still get cleaned up when you stop running the program. When you actually hit the stop button, it'll actually clean up. This function will remove the given data structure from memory, freeing up resources it was using and removing all values that it contained. This function should always be used when you are finished using the list to prevent memory leaks that can slow down and crash your game. Okay, it says memory leaks. But I still think it gets cleaned up when you shut down your game. But to be safe, you can do cleanup event and do this. So when your game's cleaning up, it'll destroy, basically. Okay, but yeah, you can also use this inside of one script, and that's what we're about to do. So I'm going to destroy it at the end of our create event. So we're using it within one script, and then we're also destroying it so it doesn't get left out. So if you plan on using this inside of a basic script and you don't call this destroy like this, okay, that will actually, all the elements inside this list will just sit in memory, and it takes up memory, obviously. Okay, so we've now created a list and we're going to destroy a list. But let's do some things in between. So let's add an element to our list. So let's just print out, let's just add some strings. So we're going to say ds list add. So we created a list and we're adding an element to it. We can add hello. And a string is an object, actually, and I went over that in other videos. But not a GameMaker object, but an object to memory, basically. Okay, so ds list hello. And then let's give it another list, or another element. We're going to add hello too, okay? And now, before we destroy our list, let's print out these values, okay? So we're just going to show a message with both of these values. So what we could do is we could say for I'm going to use var. Anytime you use var in a script, basically at the end of the script or when the script goes out of scope, the variable will automatically get cleaned up from memory. So this will get taken out of memory, okay? So if you use var in a for loop, when the for loop is complete, I believe, yeah, when the for loop is complete, this value will get removed from memory. So it actually cleans up memory. So anytime you're using like a temporary variable like this, it's good to use var, especially in for loops. So let's do I equals 0, and we're going to go until I is greater than or equal to the size of our list. And the size of our list is basically how many elements are inside of it, okay? So this should be 2 at the moment. So if we do ds list size, and then what list are we checking? We're checking our list. Then we're going to increase I by 1. Okay, so what this is saying is set I to 0, and as long as I is less than the size of our list, which is going to be 2 in this case, because our list automatically incremented its size when we added an element. So this is going to return 2. Then we're going to add another, we're going to increase I, and then we're going to do whatever's inside these brackets. That's a basic for loop, but you just need to understand that ds list size is just returning 2 because that's how many elements we have in our list. Okay, so we're going to print out the value of each of these. We're going to use show message, actually. So we're going to show message, and what's the message we're going to show? We're going to show ds list. We need to find the value at a certain position. So this is index 0. I'm going to go ahead and type these out. Index 0. Where it was created. When the script, sorry, I'm reading a comment. When he says, when the script ends, the var remains no matter where it was created. What do you mean by that? Because this should clean up. I should get deallocated from memory, the way I understand var. When the script ends, the var remains no matter where it was created. The var keyword, I believe, takes it when it goes out of scope. Let's go ahead and look at that. So a local variable is one we create for a specific event only and then discards when the event has finished. The only exception to this is in the script resources, where a var declared variable is local to the script and then discarded. Oh, was I wrong? Or sorry. I'm making sure I'm right. I'm not saying that you're wrong. I'm just making sure I'm saying correctly. Var will clean up at the end of the script. Okay, explain that a little bit more. Var, yeah, okay, you got it. All right, we cleared it up. Var will clean up at the end of the script is what he's saying. So this won't clean up after the for loop, but when this event is complete, it will clean up. Okay, that makes sense. I just thought maybe with loops it took it differently. We could actually check that in a minute. But anyway, let's get back to it. Show message, and we're going to show, oh yeah, I was typing out the indexes. Index 1. So yeah, this is how it's indexed. It's just like an array. So we have the first element added, and then the add function actually adds it to the end of our list, okay? So it's going to be index 1 in this case. And then we're going to show a message. We want to show the message that our I is currently on. So it starts on 0, so we want to show hello first. So what we do is we do dslist dot, or not value, dslist, where's it at? I forgot the function name. Find value, okay? And I don't really like this name, to be honest, for this function. It should just be dslist value or something. Find value is weird. But what it wants is what list to look at. So we're going to point it to our list. And then it wants the position in the list to get the value from. And we want to get the position of I, okay? And that's simple. And now if we run, oh, I got to create a room and add this to it. Boom. And now if we run the game, we should see hello as one message, and then when we hit enter, we should see hello too. Oh, data structure with index does not exist. Did I do this wrong? Position I, data structure, our list, our list, our list. Wow, I wonder if this destroy just messed us up. That'll be really interesting if it did. Let's see. Or did I do something else wrong? Data structure with index does not exist. Index 0. Position. Yes, less size. Spell something? Oh, I didn't add it to... I just gave the element. Okay, so you have to specify our list. Okay. So you have to tell it what data structure to add to. It's just one of those things with GameMaker that we have to do. In other languages, you could do something like our list dot add. So in Java, this is how you do it, right? Hello, which would be quite nice, but we can't do it like this. So we have to specify what list we're actually adding the values to. And then let me go ahead and put that dslist destroy at the end. Make sure we're cleaning up our list. Okay, let's see what happens. Okay, so we get a message with hello, and then we get a message with hello too. Awesome. So now let's insert at a specific position in our list. And this is one of those things that makes lists better than arrays in a sense, or better to use. Oh, baby. Oh no. Give me your tablet. Daughter's phone died, or my phone died. She doesn't have a phone. I was letting her watch YouTube. Okay, so let's see. Let's insert in the middle of a list now. Okay, I'm gonna go ahead and read a couple comments because I got a couple people. Backpack? Be done in a little bit. Okay, let me read some comments. I know this question is off topic, but I have messed with fantasy No, I have not. I'll get back to that in a few though. The DS add also allows adding multiple items in one call. It may be useful. I actually was not aware of that. So let's go ahead and see what he's saying. So he's saying DS list add. You can actually add multiple items, and I was not aware of this. Oh yeah, you actually can. I actually was not aware of that. So what you can actually do is you could say hello 3. Thank you for that, by the way. Hello 4. Hello 5. So technically this should work. So let's go ahead and see what happens. So this will actually add just like if we called 3 adds. If this works how I think it'll work. Hello, hello 2, hello 3, hello 4, hello 5. Yep. So you can actually give it a more than one basically argument. I wonder if it has a max. Let's go ahead and read about it. So optional values to be added to the list. This function take further optional arguments, as many as you require. So yeah, you can do as many as you want, just like that, if you're just adding a known list of elements, okay? Awesome. I wonder if you can add an array that was already created. Anyway, we'll get into that later. So now let's add into the middle of this list somewhere, okay? So let's say DS list insert, okay? This is the function we use if we want to insert at a specific position in our list. So we're going to use insert, and then we're going to give it our list, and then we're going to give it a position. So let's insert it at position 2, okay? So position 2, you have to remember when you're doing these things that these lists and basically all the data structures are going to be starting at index 0. So when you say I want to insert at position 2, it's actually going to insert kind of right here. So you might at first think it's going to replace where, or not replace, but insert where this hello 2 is, but that's incorrect. It's actually going to insert after the hello 2, okay? So position 2, and let's give it a value to place. So this is going to be our inserted value, okay? Awesome. So now what's going to happen is, even though our insert is called after these 3 things, actually these 5 elements are inserted. Go ahead and say this is 1. So after our 5 elements are inserted, this is going to get inserted at that specific position. So we should actually see this come up as our 3rd message, our inserted value. One, 2, and then our inserted value. Awesome. So you can kind of see how this is really nice. Maybe we do this insert and then we want to do DS list shuffle. So maybe you're wanting to randomize the order of your list. You could do the shuffle, and it's going to basically shuffle your elements for you, which is kind of useful in some circumstances. I'm trying to think of one off the top of my head that you'd want to do. Hello 4, hello 1, hello 3, hello 2, our inserted value, hello 5. Awesome. So you can see it completely shuffled our list. Awesome. So let's see what other functions we have real quick before I move on. Make sure we're not moving on too quickly. We have add, we have clear, which if you do this, basically, if we do it right now, it'll give us a bug. It's actually going to erase everything from your list. So it's going to clear it out. It's going to take away all these elements. Your size is going to go back to 0. And you're not going to have any elements in your list anymore. Okay, and then we have DS list, destroy, we already went over, empty. Wait, did I get those wrong? What is clear? What's the difference between clear and empty? Might have said wrong. With this function, you can clear all data from the given list data structure. It does not destroy the data structure. Wait, what is the difference between clear and empty? Oh, sorry. Empty returns if it is empty. So if you were to call DS list clear, our list, it's going to delete all the elements. And this is actually going to give us an error because we're trying to look at... Oh, this won't give us an error, actually. Sorry. This should actually just skip the show messages. Okay, I will in a minute, baby. Watch. 5 minutes, all right? Okay, so we didn't get any errors because we're actually checking the size. But if we were to do something like, let me copy and paste this show message. if we were to do something like access the first or the second element in the list, it doesn't exist. So this is going to actually be out of bounds. It should give us like an out of bounds error or something along those lines, saying, oh, maybe undefined. Okay, so it's just saying that that position is not defined. That's kind of odd. Did it not decrease the size of the list? I thought it would give like an index out of bounds unless GameMaker handles this for us. Let's print out the size of our list. Yes, list size. So this is going to, basically we're about to figure out if GameMaker just handles these data structure out of bounds by returning undefined, or if maybe something else is going on. So string, I'm going to convert this to a string. I don't know if it's needed necessarily in this case, but I didn't tell it what to give me a size of. Dang it. Our list. Oh. Our list. So we're going to get the size of our list. This is going to tell us how many elements are in it, and I think it'll be 0, to be honest. Let's see. Yep, 0. So GameMaker actually handles the out of bounds errors for you by returning undefined, which I wish it didn't do, because you won't know necessarily if you're going out of bounds until you figure out what it's returning. That kind of sucks. Okay. So you can see clear basically deletes everything out of our list. Empty will check if our list is empty or not. So let's go ahead and print out a message. Show message. And let's say we want to show a message. I'm going to convert to a string. It's going to be dslist empty, our list. This should return 0 or 1, basically true or false, saying if our list has any elements or not. So instead of using, you might use check to see if your list has any elements by saying, is dslist size less than or equal to 0, or equal to 0, then that would be empty, right? This is that exactly what this does. So it returns true because our list is empty, okay? And let's do the same thing right before we clear it out, and this should return false. So this message right here is going to return false because it's right before the clear, and then it gets cleared out, and then it's going to return true. So our list is not empty, our list is empty. There you go. So that's what empty does. And let's see, dslist. Let's see, we have find index, find value. Find value. We already did that. Find index. So you can actually get the position of a certain value. So for example, if we wanted to see what the position of hello2 is, we could say dslist. Let me go ahead and get rid of some of this to clean this up for you guys. Let's get rid of the inserts. Okay, so we're going to do find index. So we want to find the index of maybe this hello2. Our list hello2. And let's go ahead and print out the value that this brings. Yeah, I am going to upload it. Thanks for coming and checking out, Coxie. And thanks for the kind words, man. Appreciate it. Okay, so we're going to find the index of hello2 object, the hello2 value. And this should actually print out, I'm going to convert this to a string. I don't exactly know when you don't need to do this, but avoiding errors. So this should actually print out 1, okay? So you can actually get the index of a specific value. So it returns 1, but what happens when we shuffle it? So let's shuffle our list. Before we do that, dslist shuffle. We're going to shuffle our list. And we're going to hit play, and it's actually going to print out the new index of it, basically, okay? So let's see. So now it's at index 2 instead of 1 because it got shuffled around, okay? So you can actually use dslist find index by giving it an index and or giving it the object, and it's going to return the index where that object is located. So yeah, pretty cool. And I'm about to go over some common usages of lists. Don't worry, we're actually gonna make a little thing. So you also have replace, which is you're gonna give it a position in the list. I'm not gonna give an example for all these functions, but you're going to give it a position in the list. So if we were to put 1 as our position, and then we gave it a new value, it actually changed the value of what's in that position. So, or it actually basically clear out what's in there and put the new thing inside, not change it necessarily. So you could replace this with whatever you wanted. Read, I'm not positive what read does. Interesting. Let's see. With this function, you can recreate a saved DS list when a previous, okay. So this is if you were saving, you can save a list to a string basically for persistence. So you could save it to a file. This read will take basically that string and it will convert it back to a GameMaker list, which is kind of cool if you wanted to save a list inside of a file or something for saving for persistence, so you didn't have to keep the elements in memory. I haven't used it, but it's really useful. Let's see, copy. You can copy a list to a new list, basically, so you can have 2 exact lists. Destroy, empty, find index, find value, insert, we went over. Mark as list, mark as map, I don't know, haven't used those. Let's see, read, replace, set. So set, shuffle, size, sort. Sorting's nice, we can go over that in a minute. I'm trying to get to an actual example though. And what is set? I think that is changing the value at a position, I believe. This function could be used, oh no, I was wrong. Used to set a previously added list entry. You will give the ID and the list will be filled to the given position and each entry will be set to 0. Okay, so the position within the list to set, you set list entry 20, but the current list only contains 10 entries. Then the list will be filled to the given. Okay, so set you can use if you want to go out of bounds and you want to set like an extension. So if you have a list of 10 values and you use set with index 20, it will basically fill from 0 or from that 11th position to the 19th position with 0, and then the 20th position will be what value you determine to set. So this is a way to set a value way past the size of the list if you wanted. I don't know why you'd want to do that, but I guess there are cases. Yeah, I can think of a couple cases that you would need to do that. That's kind of nice. Let's see. Let me go ahead and read a couple comments. Can't watch it yet either. Will the full video be available or just segments? Any plans to ever finish the Spelunky map tutorial? Yes, I am going to finish. I have a couple adjustments to make on the Spelunky thing. I do plan on doing it. As I said, I'm moving into a new house very soon. So I'll have a little bit more privacy and I'll have a room that I'll be able to record videos in a lot easier than being in my living room because I'm in an apartment currently. Can't watch it yet either. Well, the full video. What video are we talking about? It says can't watch it yet either. Oh yeah, this video is not up yet. I'm still streaming. Hello. Okay. So we kind of went over how you can use lists. Another little quirks of lists. You can actually put objects in a list, and in our multiplayer series, that's what we're actually going to be using it for mostly, is storing objects. So if I create an object and like I wanted a list of clients, okay? So I have a client object. I could do DS list add. Let me get rid of this. I could do instance. All right, so we have instance create layer. I'm just going to create an object and it's going to place that basically a reference to the object in our list. So I'm going to create an object X, Y, it doesn't matter. Layer instances is the default layer. And then let's do clients. So I'm creating a client and actually, yeah. So we're going to do this a few times. So you want to have a list of clients. So I'm creating multiple clients. And now let's print out the ID of all of our clients. So we could show a message. Let's do... Oh, I have an idea. Let's print out what our write function actually prints out. So we can use dslist write. And I've never used this before, but we're about to see what this does. It's actually going to write our entire list as a string. So it'll be kind of interesting to see what this actually does. Let's not shuffle right now. Oh, this is kind of scary, actually. I don't know. This should just be the ID of the instance, I believe, as the element. Okay. Or the hash. I think this is the actual... Ooh, I don't know. Yeah, I don't know exactly how this writes out. I think that might be, let's see, the function returns a string, can be stored and transferred to another object using read. It's not human readable. Okay, so they have kind of they have an encoding of it somehow. So we can actually test if our stuff's working out. We're gonna have to use a for loop. Let's do for. Let's iterate through our list. So we use for var I equals 0. I is less than dslist size. We're gonna get the size of our current list, which is going to be our list, and then increase I by 1. Show a message. Oops, messed up. Show a message. We want to show string dslist find value our list. Now we don't actually want to print out the object. Yeah, actually let's do print out the object, because I'm curious to see exactly what it stores. I think it just stores the ID that gets created. Yeah, because this returns the ID, so it should just be the ID of the object it prints out to us in messages. So we have 1,000, or what is that, 100,002, something like that. 1 million, I don't know. Can't read numbers. So we have 10003, 10004. This is all the IDs of our instances, actually. So we can reference these instances just like this. So for example, I could say dslist find value our list. Let's get the first one, and I could say dot name equals jbob. Okay. Now this looks kind of funny. I believe this will work in GameMaker though. I'm pretty sure I've used it like this. And let's go ahead and set different names for 0, 1. Oh, sorry. This is confusing. 2, 3, 4, 5. So 1, 2, 3, 0, 1, 2, 3. Let's set the names for these guys right here. Let's say jbobo. I'll give my name. Let's see, who else do we have in here? TM CICUURD. Then we have Ingvar. All right, sweet. Well, I guess I'll make this gloomy toad. All right, and now let's print out the names of all these guys. Let's get rid of the ones we aren't using so we don't get a variable doesn't exist. Okay, so we're gonna show a message, and what we want to show is dslist find value, and we're gonna get a value from our list, and we're gonna get a value at position I, and then we're going to print out their name. Okay, so I do dot name. That should print out each of these guys' names. I hope this works. If not, I know another way to do it. Okay, unexpected symbol. So we can't do this. There's gotta be a way. That's really annoying, actually. Can we do it using accessors? I haven't got to accessors yet, but let's go ahead and try it. Our list 0. And I'll explain this in a moment. Don't freak out if you haven't ever seen this. I just want to see if this works real quick. Let's see. 1, 2, 3. And that'll be nice if this does work. Oh, it should give me an error here. No? What? Okay, so you can't set something using that, but you can get a value. Okay. Client name 1, 2, 3, 4, 5, 2, 3. Oh, I need to delete one more of these guys here. Okay, so I guess I'll go ahead and talk about accessors. So apparently, to read a value, we can do this. But to actually set that value, this did not work, which is kind of irritating. But these are accessors. So you can tell this looks kind of like an array, but I have this weird bar in front of it. And that's because this is a list. So we can actually access the elements in our list using basically just like an array. So accessing an array element would be like this, right? But since it's a list, we have to use a bar. This is saying, hey, GameMaker, that we know this is a list. Go ahead and give us the value, okay? You can set and read. Set and read. Was I doing something wrong? See, here's what I had. Sorry, I got a comment in the comments if you're watching this in the future. It says you can set and read. This gave me an error, I think. Let's see. Get rid of this one. Out of bounds set. Oh, you're talking about the set. Okay. So back to the accessor, sorry. Yeah, our list bar, and then give it the index, position index. Yep. And basically this is saying, hey, get us the value of this at this position, okay? Essentially it's doing the same thing as the find value thing, but yeah, we could do this, and then down here, instead of find value, our lists. This is what you're saying. I just didn't get there yet. I was aware that you can read like this, but 1 second. So this is kind of a more efficient way to use it. Not efficiency as in performance, but efficiency as typing and readability. If you know what you're looking at anyway. So the bar is just like saying, I know this is a list, give me the element at that position. And then we're setting the name, a name variable for that element to something. And then down here, we're reading it. So you can see I'm just getting that value. So if I hit play. So it's printing out J Bobo, Gloomy Toad, TM Seared, Kickard, Ingvar. So it's printing out our names. And this is how we are going to be using basically the clients and our multiplayer stuff, okay? So you could see we could add clients. We could set other variables, like if I wanted to set like ID or like client ID. So ID is a built-in variable. This is annoying. So client ID, I could set all these, and I could set it to like 0, 1, which I guess you wouldn't necessarily need to do it in this case because basically setting it to the index it is, and there you go. So I want to go ahead and move on. We've kind of went over lists, and now you know about accessors. This is how you can access a variable. This is essentially doing the same thing as DS list find value, but it's a little bit more readable, and obviously you can see we can actually use a set function with this. So yeah, that's quite nice. Let's get to a new data structure now. Let's get to stacks. And I'll give you an example of how we are going to be using stacks. And also, let me move back, sorry. As you can see, we can store instances. We can also store other arrays in lists. So if you have an array of elements or even another data structure. So let's say, let's see, list index 1 equals ds list create. Okay. You can actually store that inside of this list, which actually is very useful, and there's a lot of uses for it, and if we ever get to that point, I'll explain it. But you can actually store a list of lists, and that kind of gets it to another dimension, basically. That sounds funny, but it is another dimension, adds another dimension to your list. So you'd actually access it by doing something like our list at position 0. How would you... Could you access it like this? I actually never did this. It's interesting. I'll mess with that another time, but I think you might actually be able to access that second list just like this. So it would look two-dimensional, basically, because it is two-dimensional. Okay, So let's move on to queues and stacks. If you want to know more about this, I will make individual videos on different examples. These are good for inventory systems, anything that needs a list of elements, or if you want to be able to shuffle and access, if you're going to be doing a lot of inserting. I haven't used regular arrays in quite a while. I basically stick with lists now because they have a lot more uses and functionality. Doesn't mean arrays are bad. There's a lot of uses for arrays as well. So I just haven't ran into anywhere I needed to use an array as of recently. Okay, so let's move on to stacks. So we know a list is basically we can insert at a specific position. We can insert at the end and it'll increase the size of our list. We can do a shuffle, we can do a replace. So what is a stack? So let's go ahead and go over to the docs and let's get into a stack and kind of read it. And a stack data structure is a so-called last in, first out structure. You can push values onto a stack and remove them again by popping them from the stack. And the value that was pushed onto the stack most recently is the first to be popped. And stacks are often used when there are interrupts to handle or when having recursive functions or when constructing a rudimentary AI for games. So we have stack create, destroy, clear, empty. You can read those. So let me summarize what this is saying. We're giving you an example. So this is a data structure that stores elements. You could store this exact same kind of elements as you can in the list we just went over or an array. So you could store instances, you could store integers, you could store doubles, you could store booleans, you could store anything, other arrays if you wanted. And what a stack is what it sounds like. So let's say you have a stack of plates. You place one plate on top, you put a plate down, you put a plate on top of it, you put another plate on top of it, another plate on top of it, another plate on top of it. Well, how do you get to that bottom plate? You have to take the first one off first. We can't actually get any of the values in the middle, any of the plates in the middle. We can't see the top of it until we take off the top one. So we have to remove an element, we remove an element, we remove an element, and now we know what's on the bottom again. That's exactly what stacks are. So let me give you, let me give you kind of a quick use for it. Let me go into Paint here. And let me go ahead and make a little graph. I'll try to make this like a square graph. Oops. Go ahead and do this. And then let me go ahead and copy, paste, select, transparent selection. Sorry, this is going to take a second to set up, but it's all right. I know my paint skills are maxed out and basically at the top of the paint game. Not that much you could do in this program, but I know it all. All right, awesome. So let me go ahead and make something like this. I know I'm gonna give you an AI example. It's gonna be interesting, okay? I promise it's gonna be interesting. Don't leave me. This is gonna be an AI example. Okay. Let me fill in a couple of these bad boys now. Go to my fill bucket. This. And then now let me get my thing like that. Get out something like this. Ba-ba-bum. Okay, so let's say you have an AI and you want to traverse. Let's say this yellow is going to be the starting point for this AI. That's too bright. Say that yellow point's the starting point for the AI, okay? And you give it an index, some positions, and you have a stack over here. Let's imagine you have a stack. Okay, so you look around you for a free position, and you can see we can only go up, right, left, or down, okay? And so it says, hey, up, and it gets the index of this. This would be like a two-dimensional array, basically this grid, and it adds this position to the stack, okay? And then we add this position to the stack, and this position to the stack, and this position, and this position. It keeps looking for free spaces. And then now it picks one at random, right? And let's say it just goes down, okay? I need somewhere it can get stuck, actually. So let me kind of make somewhere that it can get stuck in. Okay, so let's say it gets down to here, and now it's stuck, okay? the power of a stack, you can now use basically ds pop. Let's read what the pop does. Pops the value from the top of the stack. This function will pop the top value of the stack, removing it from the stack and returning the value that was stored there. Okay, so if we do a pop, we pop this off and return the value. And then we do another pop and we return this value, okay? And now we have this index. So using this index, we could say, hey, we want to pick the new position or a new random position. Now, it's better to use queues and stuff. We'll get in that later. I actually did the same example because we're going to be using a breadth first search algorithm in one of the other videos. And if you're interested in that, I'll link it. But basically, now we have this position because we popped it from the stack. We can undo basically our steps. We can go back. So even my undo thing, this is probably created on a stack, right? So if I'm hitting Control Z and I'm undoing, it's because there's a stack of things that I've done in the past. And as I hit Control Z, it is bringing states off the stack or actions, and it's undoing them. So it's actually, we're creating a stack right now by inserting these elements. I'm hitting Control Y to basically go back, and then, or Control Z to go back, and then Control Y is redo. So there's probably a redo stack and an undo stack. And you could see it's sequential order of what actions were taking place. And that's kind of what stacks allow you to do, is this kind of thing. So for example, I could actually do this. Let's say we're adding values to our stack right now, because we are adding values, and now we're going to pop from the stack. You can see we're actually popping from the stack. This is what it would do if you wrote a stack implementation of this, like in GameMaker, and you were making a paint program. You would probably use a stack. And now we're popping, and I'm placing back on using my... Basically, there's probably a stack that keeps track of when you select undo. When you hit undo, it adds your undid value to a new stack. That's the redo stack. So now when you want to redo, it's pulling from that stack and adding that back onto the undo stack. It's kind of weird, but that's essentially what's happening, is we have an undo stack. Okay, so that's one use of stacks. So you can use stacks when you want to be able to undo things. So let's go ahead and go over a quick example of how to use this, how we're going to use it in our multiplayer example. We're going to use it by having a set of client IDs. So let's say you want to have 50 clients, okay? And you want them all to have unique IDs. Well, what you could do is you could fill a stack with basically numbers from 0 to 50. And when a new player joins, you want to assign them one of the values from the stack. You just pull one off the top, right? And that's it. You just pull one off the top. The stack size automatically gets decreased when you do that pop. You get the value, and let's go ahead and implement that. So what we do is we do the same thing. We do ds stack create. Okay, and now we need to assign that to a variable. So we say client IDs equals ds stack create. Now we need to assign some values into the stack because right now it's empty. So how do we do that? Let's just do a for loop. Unless they have a convenience function that I missed. Let me go ahead and look, make sure there's not. ds empty size copy top pop push top. Okay, read write empty clear. Okay, nope. No like convenience method for this. So we're gonna do for I equals 0. I'm gonna use var to make it correct. And then we're going to set, what's our maximum amount of IDs that we want? Let's say max IDs. We're gonna set that up as a variable right here. Max IDs equals 50. And I++, standard for loop. And now let's add all these IDs to the stack. Okay, so let's do ds stack push. This is going to put a value on top of the stack. And let's see. We're going to push to our client IDs. And we are going to push the value of I, basically. Easy. And next, down here, let's do another for loop to iterate through our stack, and basically we're going to print down here in the debug console the values of our stack. So we're going to do for var I equals 0, I is less than ds stack, we can use the size function once more. Size. And we're going to get the size of our client IDs. And then we're going to use I++. And we can do, actually, this is a bad way to do it. I'm telling you a wrong way. Because what happens is when we use pop, when we pop an item off the stack, the size of our stack decreases. So what's going to happen is this is going to get less and less. And that's not what we want when we go through a for loop. So how we actually can basically read values off a stack in a more effective manner than a for loop, since this size is going to be changing every iteration basically, because when we pop a value off the stack, the DS stack size changes. So next time it looks, the stack size is going to be different. So technically, our I value could become greater than the stack size because our stack size decreased. And if I was at 50 and our stack size decreased from the previous iteration, I would be 50 and our stack size would now be 49, which isn't what we'd want to do. And it wouldn't even get to that point, to be honest. So instead, what we're going to use is a while loop. So what we could say is while DS stack empty client IDs is the one we're checking, and we're going to say while the stack is not empty. What we're going to do is we're going to read the value off the top using DS stack pop. So we're going to pop the value off the top of the client IDs. And we're going to print that out. Show debug message. And we're going to show what value is popped off the top of the stack. It's that simple. Come on, value. Okay, so that's going to print out down here, guys. So let's go through what this is doing. We're saying while this is true, basically while the stack is not empty, we're going to keep doing what's inside of here. And remember, when we do a pop, it's grabbing the value off the top of the stack and essentially removing that value. So this is decreasing our stack size every time this gets called. So eventually our stack will actually be empty because we're reading off of it. So let's go ahead and hit play. And we should get a list of numbers down here. And you're going to see something interesting with this, and I'm going to explain it after it happens. Let me go ahead and close this out so we can read what happened. All right, so it started at index 49, which is what we wanted, because remember, these are all 0 index based, so there actually are 50 elements in our list, but it only goes up to 49 because we have 0. 0 counts as an element. So there's actually 50 elements if you include 0. And you'll see it printed the numbers backwards. So if we were actually wanting to assign client IDs, that would be kind of odd. I mean, it wouldn't matter because they probably aren't going to see it. But wouldn't you rather start at 0 and that, like, your first user would get client ID 0? So what we'd actually have to do is start our I at max IDs. So we'd start from the top. We'd start at 50, and we would add them on the stack in a decreasing order. So we'd do as long as I is greater than 0, basically. Then we want to subtract I. And this is going to add them to our stack in reverse order. So when we read from our stack, we'll be reading with the newest element first. Because remember, when you do a pop, it pulls the newest element from the stack. Well, in this case, what is the newest element in the first version we had? Well, the newest element was 50 because that was the newest one put on. So that's going to be the one that's read first as well. So you can see now that we've made that change. We're actually not getting indexed correctly, but this would work too if you were just doing client IDs. You can see that it printed out our basically 1 first because that's the one that gets put into our stack at the latest time, the newest element. And as we're popping them off, that's what we get is an increasing order now. So what you'd actually need to do if you wanted the 0 index based, you'd have to do as long as I is greater than -1, and you wanted to start at max IDs -1. So that would actually start at 49, and then it would go to 0 instead of only going to 1 in this case. So it's a little bit different in the way it's implemented, but yeah, that gives you 0 to 49. Okay, And that's basically it on stacks, guys. They're pretty simple, nothing really complicated. And now we are going to get into maps, okay? So maps are going to be used pretty extensively, all right? And what are maps? A map is basically a key value pair, okay? So given some key, there will be one value assigned to it, and you cannot have duplicate keys. So for example, let's say I wanted to have a, everyone has their own name, or no, let's not do a name. Let's do a multiplayer example. Let's say you have an IP address. So you have like 192.168.168.1.1, whatever. So this is an IP address, and everyone has a unique IP address, right? So there's never gonna be any duplicates. And we wanted that IP address to reference a client ID, or maybe just a client object. Let's go ahead and do that. So that ID references a client, okay? So you could say, when we receive an IP address from like some user, we could say, hey, this is the IP address. I want to get the client associated with it, okay? So how would we set this up? First, we have to add the values. So let's say ds_list map, ds map create. First, we have to create the map. It's just a blank map. We're going to assign this to client, let's say IP map, okay? And now we want to add a value. So we'd say ds map, what is the command for GameMaker? Ds add, I guess it's just add. And we give it the, hey, we want to add to the IP map. What is the key we want to add? So let's say we were doing networking. Let's say this is called the received IP, basically the IP address that we just got from a message that we received. So we just say received IP. This variable doesn't exist in this case, but this is just an example. And let's go ahead and set that. Received IP equals 192.168.1.1. And I'm just saying this because the IP is actually provided to us in the networking functions. When we receive a message from another user, we actually get their IP. So yeah, we would actually have access to this. And that would be the key. And now what would be the value that we wanted to associate this with? Well, this would be like a new instance. Instance create layer. Okay, and we're going to create it, whatever, x, y, instances, what object, we're going to create a client. There you go. So now they're actually stored inside of this map. Now let's make a couple more. Let's just kind of duplicate this. And we're going to change the last digits to these to make them different. And we'll see. I want to read what map does exactly. Adds a given value and associated key into the map. This function can be used to add a set of key value pairs. You can check this function to see if it was successful or not, as it may fail if there already exists the same key in the map. So if you tried to add the same key twice, so if I did this, and I tried to do this add twice, you could see both of these IPs are the same. The second one will probably fail. And the reason is because this key already exists in the map. You can only have one of a key in a map, so they have to be unique in the data structure. So you can have another map that has the same key as a different map, but inside of one map you cannot have duplicate keys, okay? And that's just the way maps work. So, yep, I made all the IPs different, and we're adding a new instance to each of these IDs. So now later on, when we want to reference maybe this client, this new client, the one associated with this IP, all we'd need to do is something like, let's say we received a message from a client, and and the message contains basically update information with like positions that let's say it changed position and it wants to update the server about it. Then we would need to update the client object with that same information. And how we would do this, let's say later 10 seconds later. This happens. We receive a message. We get a new, we get our received IP to be 192.168.1.2. And that is this guy up here. So this guy just sent us a message, and he wants us to update our client. So all we do is we say referenced client equals ds map find value. And what map are we checking? We're checking our IP map. And what's the key? It's the received IP. Okay, so this is actually our client that is going to be referenced. So it's actually, this is going to return this instance, okay? So now what we could do is we could actually say referenced client dot x equals the information we found. So we could just say 100 referenced client dot y equals 200. And as you can see, you could actually now treat this as if you were just calling or referencing this object, because that's what you did. You got an IP and you said, hey, find the value of this key. So it went to this key and it gave you the value. So yeah, that's it. So simply, that's it. So we can actually print out this client now, or actually, let's just say, I should do show message referenced client.x plus separate it by space referenced client.y. We actually need to change these into strings. String, because it'll give us an error right now because it's trying to interpret those as numbers and not strings. So let me go ahead and string. Okay, so it's actually going to show us a message. I'm going to write some in front of here. Client's new position. Oh, I should be maximizing this and all that. Sorry, guys. Client's new position is the stuff. And let's hit play. So it's actually finding the value of the client at that position. There you go. So you can see their position was actually updated, okay? And for you to see even better, and now we can try to use accessors like we learned earlier. And to use an accessor for a map, you use a question mark instead of the vertical bar like a list has. So you just do a IP map, question mark, and then you give it the key, okay? So we do received IP. This does the same thing as the find value, basically, all right? But you can do it just like this, IP map. So when you see these question marks, you now know why. Received IP dot y. So this right here basically returns the same thing that this would return, okay? Let's go ahead and rewrite this. It's going to do the exact same thing, but it's just written differently, okay? Using accessors. Received map. So what we can actually do to make this even easier is I'm going to name this key. I'm going to rename received map to key, so you kind of see exactly what's happening. Okay, there you go. So it's finding the value given this key, okay? Now if we hit play, we should actually see this message pop up just like we did before. There you go. So it gets the new position. And yeah, that's it. You basically, it's just a key value pair. That's all a map is. It's just going to be a lot of keys that are all unique, and they all store a value. They all map to a value. That's it. So a key maps to a value. That's it. I don't know what else to say about it. Let's see. A key maps to a value. Okay. The keys are unique. Keys have to be unique. You can have unique keys all pointing to the same value. For example, you could do something like this. Let's say inst equals, let's just do this thing. So we're saving inst, and then let's store inst as the object. So the same variables are going to be stored for all these different keys, which is completely useless, but just for example. This will run just fine. So you're storing basically a reference to this object in each of these mappings. So all these maps point to the same object. So you could actually, for example, oh yeah, this will be interesting. Let's set the value of our referenced client to this mapping, but let's use another mapping, and I'm just going to do this because remember you could do this because these are our keys. I'm actually going to get the position of not the one that was changed here, or supposedly changed. This should, I think, return the same values on the message. Yeah, it does return the same values because it's referencing the same thing, but I didn't know if GameMaker is going to do something weird here, like make copies or something. I don't know what I'm thinking. But yeah, so you could see that we mapped the same instance to all these different values. And then I said, hey, this is the key that I want to reference, and the reference client is the instance returned by this. And then I'm saying referenced client, I'm changing their position. But now I'm actually using a different key. But since they all reference the same instance, this is going to return the same thing as if I were to do 3. And it's going to return the same instance. So if I run this, even though this one is a different mapping, since they point to the same object, you're going to get the same thing. That simple. Yeah, so I'm going to go ahead and take questions. If you guys have any questions about data structures, and also at the end, before I get there, yes, you would use ds destroy when you're done using these. If you want to use it throughout your map destroy, sorry. IP map, yep. That cleans it up from memory. That erases everything in your map and removes the reference to the map in memory. So you use this whenever you are done using the map, basically. So if you guys have any questions about data structures, maps, whatever, now's the time to ask, okay? So if you're totally confused, let me know and I will explain it. I'm kind of done talking about the 3 main data structures we're going to be using. We're going to be using maps a lot. Fundamentally, to be able to even network in GameMaker, you have to use a map because we have to use something called async load, which is a map that when we receive a networking event, this is what has all the information. So for example, we have to do stuff like IP. This is how we get the IP of the user that sent us a message over the network. So every time we get a networking event, we get a map that's this async load, and it has some properties in it that we use to get objects. So please ask me questions. DS map add list and DS mark as map is for JSON and DS within DS. Yep. So there are specific functions in a map to output to JSON. And if you don't know what JSON is, you can kind of see it simply. If I go to my Visual Studio Code here, come on, refresh. Oh, I filtered out the stuff. Also, if you haven't seen Visual Studio Code, I just uploaded a video on how to use this with GameMaker, and I'm basically going to be using it personally for all my stuff. Let me go ahead and get rid of these 2 lines. All right. So this is a JSON file. Your objects in GameMaker are basically JSON files. If you have a room, different views, your GameMaker project file is a JSON file. This is a JSON file, and these are just maps. Okay, so you have a parent object or parent project key that basically contains a list of things. So this would, in GameMaker, this would be like a key in a map, and its key, when you reference it, when you told it to get the value, it would return a list, basically. I believe, yeah, this is a list. And it would be it would return another map. That's what this is. So it would return another map, basically, that would have the ID, the model name, MVC as its own keys. And its values would be these second objects here. And in between these brackets would be a list. So it would actually return like a DS list type thing. Yeah, this is JSON. And that's basically what this is it's a map. Parent project contains another map, basically. Or no, it contains a list. Basically, there's nested data structures inside this. I don't know how to read it, like looking at it, but yeah, it's a map. Or it's JSON. And your objects have JSON. This is JSON. The map ID is a key, model name's a key, MVC is a key. These are the values. Event list is a key that maps to a list. This returns a DS list type thing, basically. And yeah, so when you do like save games or you have a map, so if you're implementing your own save functions in GameMaker, you could use a map with the keys being all your variable names and the values being all their values. And then you can use GameMaker's write functions to write that map as like a text file, basically. So it would write something like this for you to save on your hard drive or whatever. And then when you load the game up, then you would say read, and it would read this back into a map that you can use inside the GameMaker. So you can go back and forth, and that's really nice. Okay, so that's that. You have JSON, and you can use the JSON functions. Let's see, let's take a look at them, I guess, since we're here. Bum, bum, bum. Maps, DS map, write. Wait, I think you have to use what does this do? Yeah, this writes as a string. You actually have to use the JSON. Let's look up GML JSON. Am I missing something? JSON decode. Or was that correct? The map write. Let me know. I haven't used this in forever. The function writes the data from a map as a string. Format, INI or text for easy storage. Okay, so this doesn't. Sorry, I told you wrong. This doesn't directly write the JSON. This writes like a map, kind of like we did in the list, that you can load back as a map. But if you want to do JSON, then you would use the JSON functions. Where's the JSON at? JSON, GML. Give it to me, encode. Lightweight. Okay, yeah. So you can give this a map. So a collection of map name value pairs called a DS map. So you can actually pass the map into the JSON encode, and it would give you the encoded. But you can also use the write, which writes GameMaker has its own encoding, whatever. That's not JSON. I told you wrong. And you can also do a list into JSON as well. So I recommend the JSON because you can actually read it with your eyes. And the DS map write, I'm sure, writes something weird. The ID of the data structure. Turn DS map into a specified map into a string format that can be written to an INI. The string can be later used. The return string is not human readable, so you're not going to be able to read it. So if you don't want people to be able to read and maybe edit it, this might be the way to go, but JSON works awesome. Yeah, that's what I was getting at. JSON, you can have a map that has a list and another map that might have a list, and they're nested data structures basically inside of them. JSON's really awesome. Everyone's using it everywhere. Everywhere. I use it at work. I use it home projects. Everyone uses it at work. Google uses it, so use it. They're awesome. If you don't know about JSON, I recommend looking up videos. You can do tons of stuff. For example, if you know about JSON, you can actually write your own GameMaker project editor, literally. You can point it at, you could write a program. I'm working on one that is for refactoring and stuff, basically. But basically, that's how GameMaker loads up your project, is based on JSON. It says, it goes to your object folder. For example, if I go to Documents, go to GameMaker Studio 2, go to like my networking, it finds this file, edit with Notepad++, no, and it finds this file, and this is how it knows where to find everything else. So you can see we have resource type as a folder, views. It reads this stuff into basically objects, because you can decode stuff. Like if you're using Java, you can use like JSON, which is like a JSON thing made by Google, and you can convert these into objects, Java objects basically, or whatever. But yeah, that's how they read it. So if you go to object, like I have my network manager, it has these different events. Where is my .yoyo file? Was it in there and I missed it? Yeah, so your .yoyo file that's all it is. It says, let's take a look at it. Is drag and drop, false. These are the different events. You can see I have a list of events. That's how it gets loaded up. And let's see, it probably has a link to its script. GM event, collision, object ID, owner. Probably the ID gets linked to the script somewhere. Blah, blah, blah. This is how it puts together your project. You can literally edit your project if you wanted using only this and editing the JSON. So anyway, really powerful. Use it, learn about it, because anywhere you go, it's going to be useful. Oh, don't read that stuff, guys. Get out of here. Anyway, yeah. So I don't know if I'm done talking about it. If you're confused, please let me know. I want to answer questions before I jump off here. So if you want to know more about something, please let me know. We just went over how maps work. If you didn't get to see it, it's about to be uploaded after I stop the stream, so you can go back and watch it. We basically talked about how a map is key value pairs. That's all. So you have a key, and then it maps to a value. So when you say, hey, find the value with this key, basically, that's it. So instead of using indexes like you would for arrays or you would for lists, you're using an actual key. And it is noted, you can actually use like, for your keys, you could actually use like, instead of received IP, let's see, if I was doing a DS map add, I could actually use the instance. So I create an instance, I can actually use that as the key, okay? Wait, that was not the correct thing to change. I could actually use that as the key, and then I could put the value being hello. So now when I looked up this thing, I would pass in an instance, an object, basically. I could say, if I were reading from it, I could do something like IP map, and then I could do something like instance find, let's find client, and I want to find the first one in the that was created in the room. So instance find is a function that basically you pass it an object to look for, and you pass it a position. Basically, GameMaker houses a list of your different objects. So if you have 10 clients, it has a list of 10 clients, and this is how you can access that list. You could say instance find at index 0 the client there. That basically returns the ID, and then this would return basically this entire thing put together would return this object that was created. Or sorry, it would return the value in the map, so it would return hello. Sorry. I'll go ahead and demonstrate it because I'm confusing myself. I have too much code here. Stuff. It's all messy. Okay, so I have IP map. I create an instance, assign it to inst. I have a DS map. I'm adding, using this as the key, this object as the key. I'm adding the value hello. So let's print out that value. So we could just do show message, and we could show the message. And let's do DS map destroy and IP map, just for good measure. Destroy it when we're done using it. And I hit play. We should print out hello. I know this looks messy and complicated. So it prints out hello. And yes, it's not recommended to use non-string. Does it not get converted to a string? Let's see. Show message. Does GameMaker not convert it? Why wouldn't it convert it? Let's print out JSON encode. Let's pass it IP map. See what happens here. I don't know what kind of message this is going to show us, to be honest. Hello. It does change it to a string, TM, so that's what I thought it would do. I think it actually has to use strings for, what am I saying? Oh, you're saying when you're converting it back into, explain, okay. Okay, so we are good. I was making sure there wasn't something I missed. So the reason I thought that it would have to be a string is because I think it has to have a string for a map to work. I think the key is always a string, and the reason is because they can hash it, and I believe this is a hash map implementation, I hope, which is going to be constant time lookup, which is very fast. So I don't believe it's actually doing a string comparison until you finds it. So when you say IP map, and you're looking for that specific instance, right, as your key, I don't believe this is actually doing a string comparison. It's not saying, is this instance ID string equal to this one? Okay, move to the next key. And it's not iterating through the map itself, okay? So I believe this is hashed. So it's actually using a hash map. It's actually constant time lookup. So this is as fast as it gets if you have a data structure. You don't have to iterate through all the elements. It's kind of like a switch block, I believe. So if you have like a switch statement, people know it's faster than using an if statement because the way it looks up the indexes and the values basically is constant time. It goes right to it. That's getting into deeper stuff, but basically it's really fast to use maps, and to perform lookups is really quick. So yeah. Oh, and 1.4 it fails? Real? Okay. So if you're using 1.4, apparently, sorry. I guess you wouldn't be able to do this, but in GMS2, yeah, the data structures are pretty good. They're pretty good. So use it. Use maps. You can store anything you want as the key. I think even if you did I want to say even if you had an array and you stored it as a key, it would be awful to do, but it might work. And I think it would actually parse it into a string for your key. Don't do it though. I don't think you would ever want to do that. Okay. Anyway, if you guys have questions, and hello, Anas, A-N-A-S. I missed your comment earlier, or your chat message, but hello. I wonder if you put a number here, what happens? So let's set E V2, and let's say 2. I want to see if this converts it to a string, because I think if you use a number, it might not work, but it might recognize that you're using an instance. Let's see what happens. Hello. Oh yeah, converts it to a string. Cool. So you can use numbers. There you go. But for general knowledge, your map is going to contain a key that is a string. Okay. I believe it's stored as a string. At least when it does the encode, it puts it as a string. I'm not positive if it's stored in memory as a string, but now we know. You can use maps. They're pretty flexible. I haven't run into any errors, and I barely ever use maps that much. We are going to use them extensively in the networking stuff. So one last chance for questions, guys. If you have a question, don't be scared to ask, and I'll explain it. Alrighty. And yeah, I guess when I'm waiting on questions, I'll go ahead and show you guys how we are going to be using maps. That's good. So this is the async load map I was talking about, and you can see we're using the accessor. So we have remote port, remote IP, remote type, data buffer, right? So this is given to us in the networking event by GameMaker. Okay, so it constructs this map for us, and it has some values that we can use, and it has a couple more than this actually. But yeah, so you can see we have a mapping of the IP that from the user that sent us the information. We have a mapping of the buffer, so this actually gives us a buffer to read from. We have a mapping of the type, which is going to be, what is type? I don't even remember. Type. Oh, yeah, so there's a couple different types. We're mostly just going to be using data because we're not using TCP. There's also connected and disconnected. And then there's a IP, already went over that. And then the ports, of course. So, yeah. That's how we're going to be using maps, using the async load stuff. So hopefully you understand maps. If you don't, last opportunity to ask a question, guys, before I shut it down. So please ask so I can answer them. I could show you right now. That's why I kind of one of the reasons I do this live. So, yeah, you can see we're going to be using stacks, lists, and lists. We're basically going to be using stacks, lists, and maps to do our stuff. So we have active clients, keep a list of inactive clients, keep a stack of available IDs, just like I've been doing. Which technically you, for your ID, no, you wouldn't want to do that. Never mind. I think that's why I didn't. I was going to say you could use for the client's ID the actual ID of, or sorry, the index of that client in the list, but the list size changes and the client IDs would change constantly that way. That's why I did available IDs as a stack. Okay, so give you guys 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. Well, I gotta let the stream catch up because it's gonna take a second for you to get that countdown, but yeah, I'm gonna be shutting it down. And if you missed the stream, it's gonna be up in about 10 minutes, 10 to 15 minutes. It will be uploaded. And yep, I'm gonna try to annotate the different spots in the videos for the different data structures at least. And if you guys could help me out, if I don't have that done and you see when I start talking about maps and start talking about stacks, please comment below and let me know so I don't have to go search it too. All right. And sorry we didn't get into any really cool stuff. I wanted to talk about pretty much the basics of it because we're going to be using it in practice when we get to the networking stuff. So you're actually going to be getting it in practice and applying it there. So I wanted to talk about how to use it, why it's used, that kind of stuff. So anyway, hope you guys enjoyed, and I will see you guys next time. Thanks for watching. Okay, I gotta shut this down somehow.